Hey guys, so in today's lesson, we begin to study static electricity. So, two words static and electricity. When I talk of electricity, we talk we, we're talking about charges. Usually, these charges are electrons, negative charges. Static means not changing, not changing. If something is static, it's not changing. Or rather, in this case, a better way a better sense of the word would be not moving. When it comes to electricity, there are two types. We have static, which is what we're covering right now, and current, which we will cover at a later stage. Under static electricity, the situation is like this. We have two objects, say two objects that are rubbing against each other. You know what happens when you're taking off your jersey in a dark room and you see sparks? You can actually hear them sometimes. Actually, most of the time you hear them. Then, if you're careful enough, you can see them. So, say you're rubbing against your jersey. You're trying to take off your jersey, actually. And then there are two things involved. You have your shirt somewhere here, and the surface of your jersey is somewhere here. So the two surfaces, which are made of different material, are going to interact. Now, what happens is these two are made of different materials. So, as they rub against each other, electrons move from one surface to the other. Say they move from the jersey, from your shirt to the green surface, going to the jersey. So they move from here to there. Now, because electrons move from here to there, this side will have an abundance of electrons. This side will have a deficiency of electrons. A deficiency of electrons brings about a positive charge. Since you have less electrons than you have protons, then you have positive charges. But a surplus in electrons or an abundance of electrons brings about a negative charge. Since you have more electrons than you have positive charges. And this here creates static electricity. We have electricity. We're talking of charges that are not in motion. The charges will stay here the way they are. And the electrons will continue to move from here to here, here to there to there. Till here we have a high positive charge. The positive charge builds up. And here the negative charge builds up. And when the charge builds up enough, that's when you get to see your spark. Now that's the introduction to static electricity. Now we go on to discuss the gold leaf electroscope. The gold leaf electroscope, the gold leaf electroscope allows you to detect presence of static charge. So it looks something like this. This is a simplified drawing of it. It's a simplified drawing of it. So something like this. We're going to have two gold leaves here. these two here, this this thing here and this thing here are my gold leaves. And this is a plate where I can put items to test if they're charged or not. So naturally, gold leaves aren't supposed to be like this actually. They're supposed to be right next to each other like this. I'll give them different colors so that you can refer to them differently. So they should be like this, right next to each other. So if I put something here that has a positive charge, what happens is that the electrons down here will be attracted to that. So the electrons will flow up and go all the way here, creating a negative charge here. Now, the electrons move from here to there. So now here we have less electrons. That creates a positive charge down here. And this leads to us, let's focus on what's happening down here. This leads to us having this situation. We have our green gold leaf and our red gold leaf. And we can see they both have positive charge. Positive charge. So what will happen is that they both have positive charges, so they will repel because like charges repel. That should be common sense at this stage, but I assume you know it. Yeah, I assume you know that. Like charges repel. So our gold leaf electroscope, the gold leaves actually will position themselves like this. They repel each other because they both have the same charge, a positive charge. So hopefully this makes sense to you. Next, let's consider we put a negatively charged object on our electroscope, gold leaf electroscope. So now the situation is kind of like this. This is my gold leaf electroscope. And then I put a negatively charged object here. So this is negatively charged. So what will happen? Easy. My electrons will move away from the positive plate, from the plate, and come down here because like charges repel. So there will be a positive charge here, not because protons went up here, but because electrons ran away from the plate. So now here, situations like this. One gold leaf, the other gold leaf, and we have a negative charge on both of them. So they will repel. Again, same situation, they will repel. One gold leaf will be like that, and the other gold leaf will be something like that. They will repel. So notice that regardless of the charge, whether the charge is positive or negative, the outcome is the same. The gold leaves repel. So the gold leaf electroscope detects the presence of a charge. It does not tell you whether the charge is positive or negative. That's one thing you should take note. Oopsies, let me add our charges here. Negative, negative. Okay, now remember what I said just right now? I said it's not the protons, it's not the positive charges that move, it's the negative charges. When you go to our atomic structure, an atom looks something like this. Let's look at helium, for example. We have protons and neutrons, which do not have a charge. Then in our orbits, we have negatively charged electrons. I probably should have explained this earlier, but well, the main thing is that you understand what's happening. So our electrons are here in the orbitals, in the energy levels. Our electrons are free to move. Yeah, I put this free in quotes, but they are free to move. While our protons here are trapped in the nucleus. They are trapped, they're in a cage, they cannot go anywhere. So static electricity comes about because electrons move, not because protons move. That's one thing you need to understand. Electrons move, protons do not move. So if this is negatively charged and this is positively charged, it's because electrons move from here to here, not protons moving from here to here. Electrons move, protons do not move. I know I'm repeating that a lot, but it's a common mistake, and it's a common mistake lots of people make. So I'm emphasizing it so that you do not make the same mistake. Electrons will move, protons will not move. Positive charges will never move, only the negative charges move. Yeah, hope that sticks.